What's up, Algebra 2? Here we are with a 6A quiz review. Found ourselves with an extra day, so we got a prep day here for the quiz. Doing a cube root of 270, x to the 31st, y to the 38th, and z to the 45th. Okay, we're going to break these apart into things that do work with the cube root, so into perfect cubes, and some leftovers. 270 is not a perfect cube, but 27 is. So we're going to break this apart into 27 times 10. Okay, x to the 31st. Remember, we're dividing powers by roots. 31 does not divide nicely by 3. So we're going to go with the next power that does, that's under 31. So we're going to go down to x to the 30th, and then have a leftover x to the 1. Okay, just a little hint, your leftover number should be smaller than the root number. If it's bigger than the root number, that means you could have done a different combination. Alright, y to the 38, we're going to go 36 and 2, and z to the 45 should work nicely. Okay, sometimes it helps to underline or draw some attention to the ones that you are going to do or are not going to do, whichever way you want to go, or you can just leave it all blank with no underlines at all. Okay, so I'm going to do the cube root of 27. That's going to be a nice 3. 30 divided by 3, we'll have a nice x to the 10th. 36 divided by 3, we got y to the 12th. And z to the 45 divided by 3, we got z to the 15th. Those are all on the outside. Then we got our leftovers on the inside. 10, x to the 1st, y to the 2nd. Alright, that's our first one. Not too bad. Break them down into things that you can do the cube root of, and then you'll have the leftovers underneath. Number 2, parentheses to a power. Power of a power property. We get to multiply powers. Multiply the powers, not multiplying just any numbers. Okay, so to prevent a silly mistake, I'm going to put 2 to the 1st. I'm going to put a little 1 power on the top. That way I remember to multiply powers and don't end up doing 5 times 2. Okay, so we're going to have 2 to the 5th, 1 times 5, and we're going to have x to the 5/4, 5 times the 4th. Now we can do 2 to the 5th power. Hopefully you remember it. If you don't, learn it. It's kind of a small one for as far as fifths go. 2 times 2 is 4. Times 2 the 3rd time is 8, times 2 the 4th time is 16, times 2 the 5th time makes it 32. You could also just type that into your calculator. Okay, not too bad. If you got those two right, you are passing. Woohoo! Okay, next up. Rationalizing the denominator when you have a combo going on in the bottom. If it was just radical 3, not that bad. 5 minus radical 3, now we've got to do something special. Okay, we're going to go with the same two numbers, but change the sign. We're going 5 plus radical 3, top and bottom. Now we're going to multiply everything on the top and multiply everything on the bottom and see what we got. Okay, so 2 times 5, that's going to be a 10. 2 times radical 3, we got plus 2 radical 3. Negative radical 3 times 5, we got minus 5 radical 3. Negative radical 3 times positive radical 3, that's going to be a negative square root of 9, which will be a negative 3. On the bottom, 5 times 5, 25. 5 times radical 3 plus 5 radical 3. Negative radical 3 times 5, we got minus 5 radical 3. And there's that negative radical 3 times positive radical 3 again. We know that's a minus 3. Okay, the whole point of picking these that were opposite signs is so these two pieces would cancel out. Plus 5 radical 3 minus 5 radical 3 should cancel out. Now on the top, we can do 10 minus 3 for a 7. Positive 2 radical 3 minus 5 radical 3 with minus 3 radical 3. 25 minus 3 on the bottom is 22. And then double check to make sure we can't divide them all by the same thing. And there is nothing that's going to work for 7, 3, and 22. So we are done. Number 4. Simplifying a fraction inside a cube root. Okay, step 1, we're going to reduce inside. Reduce inside first. Then we're going to work to make the denominator perfect. The bottom of the fraction perfect. Because we can't have leftovers on the bottom, so we want the bottom to be perfect so that I can do the cube root of everything that's on the bottom. Third thing, we're going to do our cube roots. All right. So simplifying on the inside first. 80 over 40 would reduce to 1/5, or if you would like to think about it, 40 divided by 5 or 40 divided by 8 is going to be 5. Put it on the bottom because that's where 40 was. Now when we're doing these powers, we get to subtract. Subtract. Okay, just a smaller example. If we had x to the 5th, that's 5 x's on the top, and 3 x's, x to the 3rd on the bottom. These 3 x's are going to cancel out 3 x's from the top, and you'd have 2 left. 5 minus 3, x to the 2nd, or x squared on the top. So similar concept here, but I'm not drawing out 17 and 14 x's. So we have 17 minus 14, x to the 3rd on the top. 6 minus 4 is going to be y squared on the bottom. Okay, we subtract big minus little and put the answer where the big one was. Okay, so we reduced inside, step 1. Step 2, make the denominator perfect. Okay, is 5 a perfect square? No. So I'm going to treat this like 5 to the 1st power. I need it to be 5 to the 3rd power. So I need 2 more 5s, or 25. I need 5 squared. I'm going to keep it as a squared for now. If you do it to the bottom, you got to do it to the top. Y to the 2nd. I need 1 more for it to be y to the 3rd. Okay, so now we're looking at cube roots of, I'm going to write 5 squared, I'm going to write that as a 25, 5 squared, 25, x to the 3rd, y to the 1st, over, and this time I know it doesn't make sense because I did the 25 here, I'm going to leave it as 5 to the 3rd here, y to the 3rd, right? 5 to the 1st, 5 to the 2nd, that's going to be 5 to the 3rd, y squared times y is y to the 3rd. So we made the denominator perfect. Here it is. Now we're going to do the cube roots. Okay, we made the denominator perfect, so we should be able to do the cube roots of everything on the bottom. The cube root of 5 to the 3rd, see why I left it at 5 to the 3rd and didn't do 125. Cube root of 5 to the 3rd is just 5. Cube root of y to the 3rd is just y. Okay, no more cube root sign for the bottom. Now the top is totally different. The top is okay to have a cube root sign left. Alright? And it doesn't always have one that does work. Sometimes it does. Do we have anything that works out on the top? Bingo. X to the 3rd. I can do the cube root of x to the 3rd, and we'll have just regular x on the outside. Not going to be able to do anything with the 25 or the y, and we'll leave that there. Cube root. So we've got x times the cube root of 25y all over 5y. All right. Last problem. Reducing radicals and combining. Okay, reducing radicals and combining. Let's look for a perfect square working out with 162. The biggest perfect square working out with 162. We're going to have 5 times square root of 81 square root of 2. Then 3 times 48. How are we going to break up 48? Perfect square with 48. Not 4. Go bigger. 16. Square root of 16 and 3. Now, once you've got a couple of these done, you can kind of cheat a little bit because we know the type of problem we have. That these are all going to reduce, and then we're going to combine pieces that have the same leftover radical at the end. So we're dealing with things that are going to be something radical 2 and something radical 3. Maybe this one was a tough one, you couldn't do it. And then we go down the line, and now we figure out, oh, it's radical 2s and radical 3s. Then we come back, and that could help us. So just another strategy to use if you get stuck. Okay, 98. We're dealing with radical 2s and radical 3s. How about 49 times 2? And 75, hopefully that's a nice one for us. Think money. We got 25 cents times 3. Okay. Now we're going to go through and do our radicals. And some of you guys could probably combine these steps or do a step or two in your head. I'm going to write them all out for right now just so we can see what's happening with this quiz prep. Going through and doing all the square roots that we can do. Okay, square root of 81 was 9, 16 was 4, 49 was 7, 25 was 5. Next, we're going to go through and do the multiplying parts. 45 radical 2 plus 12 radical 3, 7 radical 2 minus 10 radical 3. And lastly, we're going to combine our matching radicals. We've got 45 plus 7, that's 52 radical 2. 12 minus 10, that's going to be plus 2 radical 3. Okay, I think this could be a really good quiz. I think this is going to be a really good test. But you need to do some work to stay sharp on it. Alright, you guys got the back side on your own. We'll take a quick peek at that before we do the quiz. And then it's just a short time after that to the test, so make sure we're ready to go. Alright, thanks for watching, and good luck.